Is it on?
Yeah. Should be. That's the standby.
One.
Yeah.
How come you don't have a save? It's not on. Detect.
That's that.
1 minute.
No,
It's
it's not.
getting hot in here.
Oh, it's the boat.
Oh, no.
Yeah.
Good.
Pretty nice yellow light.
Ah. You do effect.
Just a second.
Where is the missing one?
The projector lamps are faulty.
He's the plus sign.
Yeah, can you see the screen? Okay. You can still see us, right?
No.
He can.
He sees
We can't see him now.
No, we can see him and he can see the screen. Yeah.
He sees the screen though.
He sees the screen and we will see him.
Fine.
Okay.
Okay. Alright. That part is hidden, I know. Anyway, basically this is a scenario. The scenario which we wanted to construct for our robot. Basically, the concept was that we get a robot to teach a kid how to work, how to write letters basically. And then the thing is that small children usually don't have control over their own muscles. So that's the reason why, through kindergarten and through nursery, you basically ask them to draw lines and circles before they start writing letters. So the original idea was basically for the robot to actually catch hold of the kid's hand and make him write the letter A, so that he develops muscle memory, and then ask him to repeat the letter and tell him if he's correct or wrong. So that was the thought process. So with that inspiration, we started the project. So essentially, since if we consider that case scenario, we have these 5 essential components of that project. That is, one, you need the hardware, of course. Then how you control these different servo motors. Of course, you need speech recognition so that the child can communicate with the robot and tell the robot if we encounter some difficulty with the letters. Image recognition so that the robot recognizes what the child has written and then tells him whether it's right or wrong. So that's what is involved. And finally, of course, speech synthesis so that, well, it can tell him to study basically. So I will show you a video of one of the initial trials that we had. So, yeah. So basically, I think Lucas said next, and the system recognized that he said next. And this is one of the initial parts where the Hubert was writing the letter A.
Maybe we will show this
Yeah.
live, hopefully.
Of course, it. Yeah.
Yeah, this was the first attempt of A when you say that.
We tried. The basic restriction of the Hubert robot is the forearm, which decreases the size of the letters that it can write. So it doesn't have proper reach. So we experimented with horizontal tables and then vertical tables, and finally decided that I guess vertical is the best.
Actually, I was the hand moving the pen.
Yeah. So this was one of the first attempts at writing A, and of course, as you can see, didn't get the proper shape. Yeah. But then we finally were able to draw the A. The reason why we are showing this video is there are 2 important parts of the system. That is that in the mechanical aspects of that's the video voice. the basic idea, I'll go to the next slide, maybe you will explain better. Yeah. The basic problem with the Hubert robots that we encountered was the strength of the servo motors. So even if we, even if we had changed the servo motors, they were not strong enough to hold the pen and stress it onto the system. So basically it was as if it was suffering from geriatric disorders. And then we tried, of course, creating a shock absorber for the system. That is, we attached this box that we see, we made it out of Lego, and we attached a spring inside it. And we tried to create a shock absorber kind of system for the pen nib. But the servo motors are so weak that they get a feedback from the spring, and it doesn't help the system at all. And then therefore finally we used rubber bands and tape to fix the pen to the system. We made another additional small change thanks to Krista. We changed the motor upside down so that it had better reach and more stability. And the last part is, I was talking about the forearm constraint. As we can see, that small shape, the entire system is based on that small H kind of shape that you see below. So because that forearm is very small, irrespective of which kind of plane you place your table in, your reach letters will always be small. So that small forearm is the basic constraint for that motion. And we couldn't, of course, apart from just lengthening the arm, there was no other option, which we didn't have the time for. Yeah. I think Lucas can take over. Yeah.
Okay. Well, we constructed basic software in C#. First, we can, this allow us to control the Hubert even before starting programming, to know exactly, we can calibrate to get to initial position and adjust each of the servos individually. And, okay. We also go to then we also implemented the movements, soft movements to move from one position to another, moving more than one servo at a time. It's not one movement at a time, but it can move up to 3 servos. So you can set the position there and tell him to move to some determined position, and it will move all the servos at the same time. And we can also, for example, when he needs to draw in a plane, we need to define the 4 points, define the plane at the coordinates with the maximum, the limits that he will be able to reach. So you can set the point and click save, and the calibration point for 0, 0, 1, 0, 1, 1, and 0, 1 of the plane that he's able to reach, and the coordinates from that plane. Then you can specify the coordinates in 2 dimensions in proportions to that plane that can be in any place in 3D, and these coordinates will be extrapolated to the space of the Hubert in 3D. Actually, okay, you go to the slide.
The previous slide?
No, next.
Okay.
Here we can see, for example, how we can specify this is in a file. The coordinates in 2D, this is proportional in these 2 dimensions, the steps to draw the letter, and how they are converted to the 3D space of, it's the position of the motors of the Hubert, basically the base, the shoulder, and the elbow.
So
and
I think that is an A, right? This
was for an A. Yes.
Yeah, I think this is for the A. So basically, we recorded the various positions for A into the system.
This is for B, Ashwin.
This is for B.
It's for B, it's for B. Yeah, it's right. It's B.
And so
Doesn't have shams.
Pardon?
No, doesn't have the shams.
Yeah, okay. So basically, we took various points on the B and we recorded those motor positions into the system. So it just basically traces its path along those points. So if we give it 2 points, it joins the 2 points. That's it.
Yeah, but the important point is that the points are in 2D, and it's translated to the specific coordination when we click save before are translated to mode. to
Yeah.
positions of that.
And of course,
Okay, yeah.
I wanted to point something cool that we did. This we could, I mean, we can control all the 3 joints in real time. So what Constantine did was he changed the program within the microcontroller itself, so that it shortens the recall time. So we were able to control all the motors in real time without much delay. Constantine, you want to add something on that?
No, not really. I mean, I think the only change I made was instead of sending one command at a time,
Yeah.
we are now sending all 3 of them at one time in one package. And so they do not queue between the PC and the basic stamp.
Yeah.
And it really makes it much faster in this case. And we tried also to reproduce with those sliders. We also tried to somehow a little bit reproduce the very nice user interface from the BioLoid, where you can control it in a similar fashion. Actually.
I think this is where we did that. Basically, we enter the degree of rotation into the system, and it rotates to that particular angle. This is what we did, which were inspired by BioLoid. Of course, so we come to the next part, which is speech recognition.
Well, yeah, it's implemented some basic speech recognition to tell the robot to do some basic things.
So whenever, yeah, I think it's Lucas saying next twice.
Yeah.
So
Okay.
it recognizes his word next and then draws the next random letter, which would be A in this case, I hope.
No, I mean it's a random letter.
Yeah.
Okay. Okay. At this point, he had only A. Yeah. By this point, the A was a little better. And the plane, we had to define a really small plane. That's actually.
Those, I think those squares that you see were the initial parameters which we wanted to point out, but
It
it
cannot
didn't
reach.
work because it cannot touch every point in the plane. So we had to keep on reducing the screen until
Yes.
we came to a very small square.
But every point can be reached.
Yes.
Actually, when we move the Hubert, it can reach these points, but when we try to do it
Do it with the computer, yeah.
with the computer, it doesn't.
Is there any specific reason for that?
That's
Did you
bec-
figure out something?
yeah, because of as I was talking about the forearm limitation, right? So the thing is that because of this forearm, for any motion of drawing A or B, both this motor and this motor have to work simultaneously. So now the thing is, the placement of the motors is such that I cannot completely go all the way through because of the motor here. So it's basically as if someone put a pillar here. So I cannot do this completely. And also we have this motor is also obstructed. So because of this, we cannot reach every single point in the plane. And plus you don't have this motion. So you can't, I mean,
Yeah, and even if when sometimes he can reach some points, another problem is that the strength of pushing the pen against the drawing object makes him even less capable of doing more things. So sometimes moving a little bit and the pen crashing, just
I think, I mean, we were thinking probably using a paintbrush would be much better than using a
or a laser
sketch
pointer.
pen.
We should have used
Yeah,
a laser
basically
pointer.
which can still write irrespective of the angle in which you place the pen. Right
Okay.
now we are using a sketch pen, but probably if we had used a paintbrush, it would have been a much better thing, I guess.
So we will
Yeah,
stop that.
I think this is speech recognition.
Yeah, it's not-
Okay, but I think I didn't understand.
Okay.
Yeah.
And that was the reason of my question.
Yeah.
Because you said that at the beginning you tried to do by
Yeah.
yourself the
Yes.
movements
Yeah.
and set the size of your
Yeah, but
robot.
when you make the movements
Okay.
by hand,
Taking the robot.
taking the robot is not exactly what he can really reach.
But my question is why? I mean, that is very strange. If
You can
are-
try. We can try that.
No,
we have the
no,
controls.
of course, no,
we will try.
I believe you. There is no
No,
problem.
I know.
But I would like to
I don't
know.
know.
No, I'll tell you the reason. The reason is because the buffer, that is, you can move from an angle 0 to 800, right? So when it reaches that extreme point, that extreme area, like 800 angle, then the motor starts vibrating because it's reached its limit
Okay.
and it gets stuck. So since the servo motor is defined, the coils are defined for certain points of angles. The coils are placed at certain angles. So you can only reach those intermediate positions based on the step size. If we reach the extreme angle, then the motor starts vibrating rapidly. We wanted to avoid that. So we reduced the the angle through which it can move.
Yeah.
So obviously the angle with which we can make it move is much greater than what it can itself move.
Thank you.
And actually, can I add something?
Yeah,
here?
sure, go ahead.
Ashwin,
Yeah, go ahead.
do you hear me?
Yeah, I think.
Okay, so actually, it's not only a limitation of the motors, it is also seems that Hubert geometry is not extremely well suited for drawing because he has joints in not very suitable positions. Try to write something. Try to grab a pen in your hand and try to write a small letter using just your torso and your elbow and your
Yeah, I guess so.
shoulder.
Yeah, I guess so.
Anyway, it won't be precise. This is the problem. So it doesn't have a hand servos.
Yeah. I mean, if we are writing something within its along its radius of movement, then it's writing quite well. So you get smooth lines. But as soon as you try to write where it has to move both the shoulder and the arm, it starts distorting. That's what we found. I think this is the image you can let.
Yeah, do you want to talk about image recognition, Constantine?
Yes, if you can hear me well. Can you hear me well?
Yeah?
Yes.
Okay, thank you. I really apologize for this. Okay, and about speech recognition. Oh yeah, good.
The image
This is
is
basically, what you see is the demonstration of how this speech recognition works, and
Image,
it actually
image,
is
image.
divided into.
it's image recognition, right?
She's
Yeah,
Okay.
I'm sorry. Constantine,
Yes.
you there, right? I'm sorry, you can continue.
Yes, I'm here.
Yeah.
Sorry. And yeah, you can see that it's actually divided into two parts. First one is recognizing the sheet of paper on the table. And in order to, in this demonstration, we are using a dark background. But it is not really necessary. We can just use any color, like for example the black paper on a white table, or the green paper on the blue table, or something like that. And what we try to do first is recognize the rectangular shape there, and you see that it's on the left side of the screen, and you see that it is not entirely correct most of the times because let me explain you what it does really. Here you see the yellow contour, and this is the result of recognition.
Yeah, I think that this yellow contour.
And
Yeah,
inside
interesting.
this yellow contour you see the green dots, and green dots are where it expects to see light color. And the red dots outside this contour is where it expects to see the dark color. And so the difference between the green dots color and the red dots color is the fitness of this shape that is recognized.
Yeah.
Also, this fitness is multiplied, for example, by the perimeter of this shape, so that it's not very small and it's not very big. And also it is multiplied by the angle deformation. I mean, this shape, if it is very much deformed, if it's not rectangular, then its fitness will be bad, because we expect it to be slightly deformed. If it's very much deformed, then it means that we recognize something incorrectly.
That's my
So
finger. It's not
those
perfect.
parameters are taken into account, and the total final value for fitness is calculated. And then, in order to get this shape, we run some stochastic optimization algorithm using this fitness function. And for example, we tried 3 different optimization algorithms, actually even 4. First we tried just the Monte Carlo method, the simplest one, just randomly pick those 4 corners and just choose some shape that has higher fitness after some 10,000 iterations or something like that. Then also we tried the genetic algorithm and the coordinates of those 4 corners, so 8 coordinates in total. There were genes in the chromosome. And so genetic algorithm works better than just Monte Carlo method, of course. And then we also tried PSO, particle swarm optimization method, where those particles actually fly in 8 dimensions. And also,
I think something's wrong. Yeah, we can't hear. Your connection is going off.
okay, now?
Yeah, better.
Okay, sorry. Then what we also tried is particle swarm optimization, where the corners were flying in 8 dimensions, and then it worked even better. And then the best result was by this differential evolution algorithm, which actually produces the best result. They are all stochastic optimization algorithms, so you can actually find about the majority of them if you take the stochastic optimization algorithms course by Martinez, which I strongly recommend you to take because it's a very, very nice and interesting course.
Good commercial.
Good conversation.
And actually, for this particular program, we first tried to implement those algorithms manually, but then we realized that it's a lot of work, and so we used the third-party library called. Oh no, it's embarrassing. I don't remember. Okay, I remember. It's called Swarm Ops, like swarm operations. Actually, if you Google for like a library for particle swarm optimization for C#, you will find this library, and it contains all those methods that you can see in the left top corner of the screen now. So, and yeah, this is the first part, and then it.
That's about it, right? What is? Hello?
No,
Yeah.
not really. This is the first part. I will finish soon. So, after it recognized the paper, what it needs to do then, it needs to transform it to deform it back so that it is rectangular now. So this is just a linear deformation. So that it provides the image with the same proportion as the original sheet of paper. And then what we do next is we apply some image processing algorithms, like we already, like the previous group mentioned. We apply erosion, I think, and also we normalize the histogram of those images, make it black and white, not black and white, but grayscale. So we do some very basic image processing here, so that we have a rather nice black and white intuition as a result, like you can see on the right side. And then what we do, we just apply some OCR engine to this image, so that we use Google Tesseract, which is like I think like the state of the art engine of this type. It is open source and sponsored by Google, so it's developing rather cool. So, and this OCR engine then tries to recognize what is actually on this image. And I think this is the major bottleneck in the whole algorithm, because the performance of this OCR engine, even despite the fact that it is a good engine, it is a very bad performance. As you can see on the right, it doesn't recognize this letter A. It says words 0. So you need to be lucky for it to recognize this letter, actually. So this is what I think this is the major problem of our project. We were unable to make this algorithm to recognize it really reliably. So I think that's all from my side.
Yeah. Okay.
Okay.
Thanks.
Yeah, that's basically this show. Yeah, this is speech synthesis, but it's nothing just show something because I think we are running out of time. Show the project.
It's not audible. I mean, basically it speaks whatever
Yeah.
we ask you to speak. I think what did we use for it?
It's the one library from C#. It's the speech library from C#. We use that library for both for speech synthesis and for speech recognition. And yeah.
And I think this is the final case scenario. So for all the problems that we had,
Yeah. Okay.
yeah, I think we can demonstrate it.
Okay. Let's show the actual demonstration.
So it's a 180-year-old man bot.
Huh?
It's a 180-year-old man bot. 90. 190.
Exactly. Okay. So I'll run.
I think it's better to turn the lights on.
Can you turn on the webcam?
Yeah, just a sec. And I guess I can bring it here so
Okay.
we can actually see what's happening.
Okay. I'll start now.
Yeah, can you see?
Can you unshare your desktop?
Pardon?
Yeah,
Turn on the light.
I see your desktop. Yeah.
Okay, I'm turning it off. Just a sec. Hold.
Stop sharing.
Maximum of 20 minutes. Maximum of 20 minutes.
Just for the presentation or with the demonstration.
Okay.
Can you see now?
Okay. I'll push start. Yeah. Yeah. Let's go. Next. He recognizes the speech. He will choose a random letter A, B, or C, and he will draw. This is C. Okay, the easiest. We'll do it again. Next. Oh, I think next. Nah, leave it there.
To draw the
He's going.
the letter in the same.
Yeah, I will.
Yeah, well, we should have. Yeah, he's drawing a B.
See.
The first letter is C and this one
Oh, sorry, it's really bad.
is. And maybe.
Yeah,
It's
that's
okay.
Yeah.
Next.
I'll just shift this a little, I guess.
Yeah, please move.
Oh, but. Okay.
Because
Yeah, but now. The C again. Okay, if you want, I can just
yeah, we can
make him
show
draw
A.
the A. Ouch.
Yeah, it wants to murder me.
He is really old. Yeah.
We can show A. I mean,
Well, I will just stop him and draw the A.
Yeah, sure, do that.
Done.
no.
Okay, now he start. Okay. He starts recognizing this, but let's see if this does something. Okay, it doesn't. Okay. Fine.
Just draw A.
Yeah. For example, this is what I showed before. When I want to draw a path, I can calibrate the servos by choosing some specific position. When I click save here, I have the options to set the plane of the robot, and then when I already have the letters, so we will load the A, and we will make him draw the A. Yeah, that's should be a straight line between those 2 points.
We're getting those distortions because the step size of the servo motor is very less, so resolution is not that good.
Well, it could be an A.
Yeah, this direction was the hardest. It just didn't move in the.
So the area which we have for motion is very small, and the step size is very large. So we have no option but to write a distortion.
Can you try to write it again, the A?
The A, yeah. He will do the same.
Oh, yeah?
Yeah.
Okay.
He will do the A
The same way, I
the
guess.
same way.
I mean, I put in a spring to create a shock absorber, but it's not helping.
Exactly, in the
Pushing
same
it.
position.
Well, that's a good repetition.
Yeah, repetition is very good.
Yeah, it's exactly the same.
Yeah.
So there's reliability
Guys,
in
do
the
you
wrong
have
way.
this?
Is there
Guys,
any
do you have this
relation
yellow paper
between
with
the
the
angle?
letter A that it's wrote once?
Well, I don't.
They could go on do that forever.
Yeah. So
That's
we
still the same.
can write the wrong letter many times.
You have implemented two webcams.
Sorry?
You have implemented two webcams.
No, we-
No,
one of
well,
two.
this webcam is there because to recognize the letter is better to have like a better letter.
Yes.
And okay, we show the recognition just to show a little bit the recognition algorithm, but I will show it.
I think we're behind schedule,
Yeah,
but
it's one
very short.
second,
Yeah.
1 second just to wait. What's looking? No, it's yeah. This is not the webcam. It's trying to recognize. No, yeah. Wait. That was. But it recognizes the paper. You can see that the paper is recognized well. So the algorithms are working very well. And the transformation to put it here.
Yeah.
But not always recognizes even that the letter is quite fine. That doesn't recognize the letter very often. And yes.
And this is the limitation of this OCR engine.
And this was what was the last step in the whole program. I just don't want to run the whole program again, but just the first time. But, yeah.
Even though we
So
are able to isolate the letter, we're not
It
able
should
to.
recognize and tell you if the letter was right or wrong, and if the letter was wrong, he will do it again, and the child, so that the children could learn how to do it.
Yeah. Okay.
So that's basically it. Yeah. And he speaks. He says right, wrong, and those kind of things.
Very ambitious.
Okay. Yeah. Very. Okay.